All right, students, I am here and I'm going to kind of go over the homework. Um, so we've got our sine and our secant, cosecant um, graphs. And probably what I'm going to do is I'm going to go through 1 through 4. I'm going to let y'all try 5 and 6, and then I'll talk about a couple of these here and then kind of talk through those. So here we go. Okay, so the first thing obviously I'm going to do is I'm going to get this to be, well, that's a nice bright green that I don't want to use. Y is equal to -3 plus the sine. And I'm going to divide out that negative pi times x plus 2 over pi y. Um, all right. Well, sine we know is an odd function because if we look, right, it's got that, like if I rotate it like that, it's going to be the same thing. So it's got origin symmetry. So if I don't want this negative here, Um, I know that if I do sine of negative x, it's going to equal negative sine of x. So I can kind of use that idea here and say, oh, okay, um, that negative pi, I can rewrite this as -3 sine of pi times x plus 2 over pi. Then I'm going to go through and, all right, so my period is 2 pi divided by pi, so 2. We'll come back to the range. The amplitude is the coefficient on the sine, which is just 1. Um, well, it's the absolute value of that. And then we'll look at intervals of increase and decrease. Hmm, Um, all right, so if I know my midline is going to be at -3. We already said my amplitude was 1. My period was 2. I have a phase shift of -2 over pi, which is a terrible phase shift. Um, okay, so what I'm going to do here, I'm going to graph it kind of like this. I'm going to put in my like 4 things here, and then I'm going to graph my sine function in this little box instead of doing axes. So 1, 2, 3, 4, 5. Okay, I have a phase shift of -2 over pi. And I know that this distance here is going to be 2, because that is my period. So because it's kind of ugly, I'm just going to do, I know that my interval or like the increments that I'm going to count by is going to be this 2 here divided by 4, which is just 1/2. So I'll do -2 over pi plus a half, and then -2 over pi plus 1, -2 over pi plus 3/2, and then -2 over pi plus 2. And then I've got my midline. I know my midline is at -3 with an amplitude of 1. So I'll go up to -2 and -4. Um, then I can look at my function, and so I'm just going to draw little dashes across to kind of help me out. And if this is sine, and I know that sine does this, um, but I know right here, that tells me it's going to be reflected over the x-axis. Now, if you don't like this thing right here, if we look at that, that just means I reflect over the y-axis, which still kind of gives me a similar to shape. If I reflect this sign right here, I would get something like that. Well, if I reflect this over the y-axis, I get something that looks like this, which would then do that. So you can either do um, like remember this identity or just kind of use your transformations and be like, oh, okay, well, that's reflecting this way. What that means is I'm going to start my graph here at negative 2 over pi, but then I'm going to go down, then I'm going to come to the middle, then I'm going to go up, and then I'm going to come back down. And I now have my sine function. And so intervals of increase or increasing all along here. So then I would say, oh, okay, well, my interval of increase is going to be negative 2 over pi plus 1/2 to negative 2 over pi plus 3 over 2. And my decrease would be negative 2 over pi to negative 2 over pi plus 1/2 union negative 2 over pi plus 3/2, comma, negative 2 over pi plus 2. So essentially, what I'm saying here is that I'm decreasing here and I'm decreasing here. So that's between these two parts. And then I increase here, and that's between these two parts. Cool. Um, all right. For the cosine graph, well, if I see the word cycle, that's the same thing as like the period. Okay, so if I do my little thing, I'm not a big fan of Mappy, but I know some of y'all are. Y is equal to 1 minus the cosine of negative 1/3 x, but I'm factoring out that 1/3, so that would be plus 3 pi, like that. Okay, well, here's the deal with this. I can remember this. Cosine is negative x. Cosine of negative x is the same thing as the cosine of x because cosine is an even function. If I graphed it, it would be reflected over the y-axis. So if I plug in the negative x, it's the same as the positive x, like the y value would be. Or, like I said, I could recognize, oh, that's a reflection over the y-axis. But when I reflect it over the y-axis, it's the same graph. So I can be like, oh, it's just really this thing right here. 1/3 times x plus 3 pi. Great. Okay, so mapping. My midline is at positive 1. My amplitude is also 1. Um, E. Oh yeah, that's the period. So my period is going to be 2 pi divided by 1/3, which is really just 2 pi times 3. So 6 pi. My period is 6 pi. My phase shift is negative 3 pi, and we'll figure out the interval later. Okay, so my cycle or my period is 6 pi. So I'm gonna make my little thing here. Oh, it didn't do it like I wanted. Boom, 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 boom. That's ugly too. Great. Okay, so I shift by negative 3 pi. And I know that I'm gonna go over like this distance is 6 pi. Oh, well, that's just gonna be 3 pi here. And then I just need to cut it into fourths. So 6 pi over 4 is really 3 pi over 2. So I'm just adding 1.5 pi to each one. So this would be negative 3 pi over 2, 0, and 3 pi over 2. And then my midline, I said, was at 1, and we have an amplitude of 1. So this would be 2, and this would be 0. So I can just and all right. So, like I said, this negative here, on the inside reflects over the y-axis, which doesn't do anything for our function since cosine is an even function. Now, this one right here in front of the cosine will reflect it over the y-axis. So our graph will actually do this. It'll be like, woo! So, or, oh, let's do the big bright little red. So it goes, and then we're gonna flip. And now it looks like, hmm, like that. Okay. Um, so I'll start low. We're gonna get low, get low, get low. Um, and then we go high. And then I'll graph my function. And ta-da, there it is. Now, you know what? I forgot the range on this part over here. The range would be -4 to -2. Here, the range would be 0 to 2, because it's just, the it's this distance here. My amplitude we said was 1, increasing by look. I'm increasing from here to here. So from -3 pi to 0. So we increase from -3 pi to 0. And then we decrease from, oh, that's going to just disappear if I write that. 0 to 3 pi. Cool. So that is how we graph those. Okay, so let's look at secant and cosecant. One thing to remember here is I know secant x is the reciprocal of cosine x. And I know cosecant x is the reciprocal of sine x. So really, the way that I graph these is I think of cosine. I graph secant like it's cosine first. And then I, and then from there, what I do is graph my secant function. All right. All right, I'm back. You don't even know I left. Um, I was one time I made a video and I forgot to record the sound, so I just wanted to make sure that I'm recording the sound. And good news, I am. I know y'all really cared so much. Actually, you probably do. You want the sound. All right, so here, mapping. I'm a mappy, I'm a mappy, I'm a mappy. Um, all right, so um our midline is -2. The 2 out front tells me the amplitude. That negative is we'll deal with that when it comes. That's gonna flip a Ruski over the x axis. Ooh, it's starting to see things. So the period, the phase shift, so we get 2 pi over 2, so the period's gonna be pi, birds by. And the phase shift, if I look, is left pi over 4, so it's gonna be -pi/4. So I'm gonna make that um, box that I made earlier. So -pi/4. Um, and we know the distance here is pi. So if I really think of it, it's pi minus pi/4. So it should end over here at 3 pi/4. If you're having trouble with adding and subtracting pi's, the way that I really think about this is it's 1 minus 1/4. Oh, that's 3/4. And then I come back and I'm like, oh, well, I didn't want to erase that. It's really just pi that needs to be added back in there. But that's kind of how I think about it. All right. Now we got to split this into 4 and pi divided by 4. Well, that's just pi over 4. So if I add -pi/4 to pi/4, that gives me 0. And I get pi/4. And this one's 2 pi/4, which is really just pi over t. All right. Um, Midline we said was -2. Ah, the amplitude is 2, so this is going to go to 0. That's going to go to -4. We go bloop-de-be-doop, be-de-be-doop, blah-blah-blah-blah-blah. And now, this is where I graph like it's cosine. So I'm going to be like, oh, okay, well, pretended like this is cosine. That's a negative. So I know that it's going to start at the bottom, go to the middle, come here, go there, and there. And then I do a little dotted line so that I know that this isn't like the real function that I'm graphing. And I am going to put in my asymptotes, which the asymptotes nicely always go through the midline, which actually, you know, and then we'll just put 0 there instead so that, it matches up with the asymptotes. And then this asymptote right here. So the asymptotes always go through the midline because that's where cosine would be 0. And since secant is 1 over cosine, that'd be 1 over 0, which is undefined. Um, and then I take my graph and I go, okay, there's secant. There's my secant graph, just like that. So I graph the cosine and then I kind of like, you know, reciprocal it. Now then I look at my range, and my range, we're going from all the way down here, like so far down we can't even find it because it's negative infinity, all the way up to -4, and then from 0 up to infinity. So my range would be negative infinity and -4 union um, 0 to infinity. And the vertical asymptotes in one cycle, so that's just x equals 0 and x equals pi over 4. Cool. Intervals of increase, well, I'd take another break. Not that y'all even know. Um, yeah, I was gonna come back and tell like a stupid joke. Um, but I was a bear because I had to do a big pause, but that doesn't really make sense. So let's get back to this. All right, intervals of decreasing. Well, if I look right here, that's decreasing there and decreasing here. So essentially, I'm going to be decreasing from, what does that look like? From -pi/4 to 0, and then from 0 to pi/4, and then from pi/4 to pi/2, and from pi/2 to 3 pi/4, these two will be the increasing. So we come over here and we say -pi/4 to 0 union 0 to pi/4. And the reason I have to split them up is because this is not continuous. We have this asymptote in the middle of this. So we have this asymptote here. So because we're discontinuous, the graph is discontinuous at 0. So I have to split them up like this. Okay. Now I do the oh, and so I do pi/4 to pi/2 onion, pi/2 to 3 pi/4. Wunderbar. Ja, so gut. Ja. Okay, let's do cosecant here. Now, what I got is I've got 2 pi. So we'll come back to that. Okay, so I'm a mappy, I'm a mappy, I'm a mappy. Yeah, I haven't even been doing the I. Um, I've just been kind of doing it over here. So if you, the eye is the like distance between these parts. All right. So Mappy, there is the midline's at -1. The amplitude's at 4. The period and the phase shift. Well, good news. There's no phase shift. And this, the way that I think of x over 3 is really just 1/3 x. So then I'm going to take 2 pi and divide by 3, which is divide by 1/3, which is really 2 pi times 3. So that's just 6 pi. So my period is 6 pi. And make big thing great. Box 6 pi and no phase shifts. So we're going from 0 to 6 pi. And to figure out what I'm going to count by, so 1, 2, 3, 6 pi divided by 4. So I'm going to count by 3 pi over 2. So that would be 3 pi over 2. I don't really like how those aren't. It's gonna bug me that those aren't like, oh, well, okay. We're just gonna, no, I don't like this. Too picky, Mr. Otto. Just like undo stuff. Whatever. Just gonna erase. Okay, there we go. And don't. So like I was saying, 3 pi over 2. 3 pi over 2 plus 3 pi over 2 is 3 pi. 3 pi over 2 plus 3 pi is going to be, I think it's 9 pi over 2. Now, if you had done 1.5 pi and 4.5 pi, I wouldn't begrudge you that. That's pretty accurate. All right. Oh, so that's an eraser. Now, the midline is at -1, and I have an interval of, or like a amplitude of 4. So -1 plus 4 is 3, minus 4 is -5, and do my little. And remember, cosecant is 1 over sine. So what I'm going to do first is I'm going to graph sine. And since it's positive, I know it will start in the middle. It will then go up, will then come down, all the way to the bottom, and then come back up. It is like a happy little sine graph. My best impression of Bob Ross. All right. So then I am going to do asymptotes. And I know the asymptotes are when sine is 0, because 1 over 0 is undefined. It's also where the graph hits the midline. And then I'm going to come in and I'm going to go just turn it uppy. It's going to get turned up like like that song. Okay. Now my range. Well, I'm coming from -infinity up to -5, and we stop. And then we go from 3 up to infinity. And we just have like this stuff in the middle that we're like, what's going on here? Nothing. Um, so my range would be -infinity to -5. It is included. Union 3 to infinity. Great. And then my vertical asymptotes are x equals 0, x equals 3 pi, and x equals 6 pi. All that pi, and none of it is delicious. Really good for a buttermilk pie. Okay, intervals of increase. Well, we're increasing here to here and here to here. So that is from 3 pi over 2 to 3 pi, non-included, and 3 pi to 9 pi over 2. So write that in. I go from 3 pi over 2 to 3 pi onion. 9 pi over 2 is wrong. So I do 3 pi to 9 pi over 2. Woohoo! All right. Intervals of decrease. Okay, decrease down like this, all the way down. From here we go down. So this is decreasing and it is going from negative pi over 2 to 6 pi. And then this one goes from 0 to 3 pi over 2. That's our intervals of decrease. So I go 0 to 3 pi over 2. Union. 9 pi over 2 to 6 pi. And I have just graphed a cosecant function. Cool. All right. I am going to give a little instruction here, but then I'm going to stop. So one thing here, I've got secant. That negative, remember, secant is just 1 over cosine x. And cosine is an even function, so even secant is also an even function. So that negative here, I'll pull that out first, and I get x plus 1, like so. Um, plus 1. So what I can do, though, is since this is an even function, or I can think this is reflected over the y-axis. So if I think of it like that, I'm just going to draw this out. And so that's secant, like this. Okay. So if I see here, reflecting over the y-axis changes nothing. So I can just also think, okay, I don't need the negative. Um, with cosecant, though, oh, with cosecant, remember cosecant is 1 over sine. So it looks like, oh, I don't want the, I just want to do the da 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 da. So we've got that, we've got that, we've got that, we've got that. And it sounds like I'm a map. This is odd. Not like, oh, that's a weird looking thing. I mean, it kind of is weird. Looks like a bunch of horseshoes. Um, but this is an odd function, which means it has origin symmetry, which if I rotate around, I get the same graph. However, when I reflect it over the y-axis, like this, these go from being up here to doing this, because that's being reflected over the y-axis. So I could make both of these positive, because when this is negative inside, it's the opposite of whatever that sign is. So I could really say, oh, that's like this. But the first thing I should do, though, is factor out that -2. So I've got the negative cosecant, -2 times x minus pi over 4 minus 3. And then I can just be like, oh, negatives go away because of the odd functionness of it. Okay, I'm gonna let you graph those. So let's come here. And oh, look at this. I have this handy dandy what a secant function looks like and what a cosecant function looks like. And I'm going to use those when I go to look at these graphs here. So one thing I do know, if I look here, 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 and oh, look, here as well, we have a midline. The midline is -1. So let's just kind of like highlight it a little bit. -1. I don't know if I like this one. What do y'all think? Okay, we'll keep it. Um, so I'm just gonna highlight the -1. Highlight. None of them like, oh wait, actually that one's pretty good. Okay, so then the thing that I look at, we could look for a cosecant or we could look for a secant. Now, one thing to know is the just like the graphs of sine and cosine, I can take this equation right here, or that not equation, that graph, and I can write an infinite number of cosecant and secant um, graphs because all secant is a, if I look at this, right, that is, let's use different colors because I don't like this one. Because it's just like not showing up. So, no, that one doesn't show up either. You know what? Let's do this. This part, and that part, that's a secant graph. Just one cycle of it. This, that, and this is a secant graph. Just shift it. Or I could even look here, here, oh, okay, there, and there is also a secant graph. It's reflected. So, what I like to do with these is just like with up here, where I have this piece highlighted. I've got this piece here and this piece here. I go ahead and just, you know, draw it in. So I am gonna just draw. Oh, I want to go through this part. So draw it in, bounce, 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 bounce. That one's ugly. Bounce, 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 bounce. Um, okay. So if I look, I can see, okay, maybe I'll look at this part right here. Oh, that's sine. That is the sine of x. Maybe, or that's just, it's like a sine function. Okay, well then this part right here and this part right here would be a cosecant, and it's at 0, so there's no cosecant shift. And then I can look and see, okay, that is a period of pi. Because we're going from here to here, or you can even look here to here as a period of pi. So I can do my little, I'm a mappy, I'm a mappy, I'm a mappy, I'm a mappy. So we know this is going to be -1 because that was given to us. And we're going from this piece right here, that's 2. That's a distance of 2. And here, that's also a distance of 2. So my amplitude is 2. Great. And then I've got a period of pi. So I know I'm taking 2 pi and I'm dividing it by p. I know that by b, and that equals pi. So b has to be 2. So my period is just um, pi, right? But b is 2. So I know what that means is if I think of this as a cosecant, so like I said, I was looking at the cosecant, y is equal to a cosecant of b times x minus c plus d. And there's 0 phase shift based on this part that I'm looking at. And then we actually don't need the E part of mappy. So it's just map. Now, I look at that and I go look at my answer choices. Well, or I can just write the graph. So I know A is 2. So A is 2. B is also 2. So I know it's going to be 2 cosecant of 2. There's no phase shift, so C is 0. So I just have 2x minus 1 because that's this part. And that's my graph. Oh, and look right here. It's A. That's so nice. Okay. But Mr. Otto, what about secant? I'm so glad you asked. Disembodied voice. All right. Well, now for secant, for the Zatzingoff, I am going to midline it. And then like I did earlier, we're gonna bounce, 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 bounce. I know that's in a song somewhere. Bounce, bounce, bounce. And those are beautiful. I don't care what y'all are saying. Um, see, pretty. Now I want to look at a cosine graph. So because I'm looking for secant, I can look at this, or I can look here. Well, if I notice cosecant normally, if I look over at this one, starts at 0, and um, so, or if I'm actually really looking at this part, that starts at 0. However, when I draw these, they're shifted either to the right for a positive one, or shifted left if we're looking at a negative one. Okay. And that's about halfway between, well, let's make that big. It's halfway between pi over 2. So what I know is that, okay, I don't want the highlighted. I know that this is going to be negative pi over 4. That's going to be at pi over 4. Cool. We already know the period is pi. Let's do, we already know A is 2. It's this phase shift part that I have to be careful with. So what I know is it's either going to be negative pi over 4 for my phase shift, or it might be positive pi over 4. Just depends. And if it's the negative pi over 4, you're going to have a negative secant of stuff. If it's the positive pi over 4, you're going to have a positive secant of stuff because of this piece right here. That's a positive cosine. That's a negative cosine. And remember, we can build secant and cosecant off of sine or cosine. Okay, so I look, oh, we have a negative one here, and I already know b's got to be 2. Ah, b is 2. So let's do this. Let's see, okay, that's 2 times x plus pi over 4. Oh, that's a shift left of pi over 4. We already know the amplitude is 2, and we know that it's, okay, let's do this one. We're gonna do green. Let's make it big and big in it. So we're probably looking at this piece. So really, we're looking at this secant graph here, the blue. And since this is flipped of this, this is probably our A. Okay. Um, so you can do similar things with these. The big thing here, right, is go ahead and draw in the sine and the cosine. And then go at cosecant from the sine or the cosine. Cool? Great. I'll even draw this one in. Right, it should start here. Oh, it should start there. Come up, come down, come up, come down, come up, come down, go up, come down. Ta-da! There it is. Cool. All right. Now, all I have to know here is your basic tangent graph. So tangent, if I remember, um, tangent, it looks like this. And anytime cosine is 0, like secant, it will have a vertical asymptote. So this is my tangent graph. Tangent, theta. My cotangent graph, which if you were in my class, at the end of the bell, uh, I explained wrong. So cotangent actually does this, and it's 0 when sine is 0, or secant. Um, and it is always decreasing if we notice. Okay, so if I look, this is a positive tangent graph. This is a positive cotangent graph. So I go look here and uh, B looks to be my positive tangent graph. And if I flip it, so I go, "Whew," it would look like that. So the negative tangent graph should just be B flipped. And I see that's, oh, C. Great. Cool. Then I go to my cotangent. My cotangent should be decreasing. And oh, D does that, and it has 0 as an horizontal asymptote, so it doesn't even cross the y-axis. So that's the positive one is D, and the negative one happens to be A. This is just this one, flipperooskied. Cool. Great. Part 5. Um, so to figure out the length of one cycle really just means find the period. So I'm going to take my coefficient here. I'm going to do 2 pi divided by pi over 4, which really is just the same as 2 pi times 4 over pi, just 1. And the pi's can cancel, and so your period just ends up being 8. So period equals 8. Write an equation of a tangent graph with okay. So this really should harken back to the days of algebra 2. You're going to have A tangent of B times x minus c plus d. Um, in general, this equation right here goes for a lot of functions and their transformations. Like if I did square root function, I could be like, okay, it's A square root of B times x minus c plus d. That should be a d. There we go. Hey, that looks like a transformation for a square root function. Oh, weird. Um, it's really, you could do that with any function. Oh, all right. So remember, A is your vertical stretch or compression. So your vertical dilation. This is your horizontal dilation. This is your horizontal shift. This is your vertical shift. Cool. So we're just going to go fill those in. So I've got A is my vertical stretch is of 2. So I know A is 2. B, the period of 2 pi. Okay. So actually, let's talk a little bit about that 2 pi. Um, if I think of the normal period for a sine or cosine graph to be 2 pi, nope, we're talking about the wrong graph. If I look here at tangent or cotangent, notice it's going to repeat every pi. So your period for tangent is pi. So I have to remember that. It's a little different than cotangent. And so then when I find the period, it's really pi divided by b instead of 2 pi divided by b. And I'm going to set that equal to 2 pi. So I need to figure out what b is. Um, so for that to happen, b has to be 1/2 because this doubled. So b has to do the opposite. So b is 1/2. And then we have a horizontal shift 3, so it's left 3, so C is going to be -3, and a vertical shift down, so D is -1. So I can go fill in the letters. So that's 2 tangent, and there's no reflection, so don't need to worry about the negative, or a negative. So then x plus 3 minus 1. That's the equation. Yay, Mr. Otto, so good. Oh, cotangent, same idea. A cotangent of b times x minus c plus d. Remember, pi over b is equal to your period. The period's 1. Oh, that's lovely. Love it. Love that for me. Oh, that means b is going to be pi. And we have a vertical stretch of 3, so I've got a is 3, b is pi. Shift right 4, so c is positive 4. And d, what did we get for d? It's shift up 2 units, so d is 2. So I'm gonna go write my equation. Y equals 3 cotangent of pi times x minus 4 plus 2. Great. That's the cotangent graph. And I'm gonna go ahead and box these so that we know what the answer is, even though I just said it. It's obvious, but there's a lot of stuff going on here. All right. So we are told here for the last problem that I'm gonna do that tangent, I want this to be bigger. We're told tangent theta is equal to A, and theta terminates in the third quadrant. So let's just deal with that part first. Got this, and this, and I know, oh, we're rotating around. So this whole thing is theta, and it terminates here. You know what? Let's go ahead and do that as a different color. Terminates there, and it makes the right triangle here. So it's in the third quadrant, and tangent is A. So I've got tangent of theta is equal to A over 1, because it's just A. Now, because it's in the third quadrant, I know that both the x and y distance, this right is opposite over adjacent, and we generally look at this angle here, so the opposite would be A and the adjacent would be 1. But because they're both in the third quadrant, it's actually going to be a negative A and a negative 1. And then I can use Pythagorean theorem to find the hypotenuse. Um, so I do a squared plus 1 squared is equal to c squared. So then I can be like, oh, let's take the square root. Square root that, square root that. And I don't want to kill any puppies. So if I look here, I cannot square root either of those individually. So I got to leave this as a squared plus 1. So I know this is going to be a squared plus 1. Cool. Great. Um, and it's going to be positive because the radius, when we do these, it's always going to have a positive value. All right, so it wants me to find the other 5 trig. So sine theta, well, sine theta is opposite over adjacent. So negative, that is wrong. It is opposite over hypotenuse. Negative a over a squared plus 1. Cosine theta is adjacent over hypotenuse. So negative 1 over the square root of a squared plus 1. And then what I can do here is I can come and be like, oh, well, sine is just cosecant, I mean, is the reciprocal of sine. So I can say, oh, that's just negative root a squared plus 1 over a. And secant theta is just the reciprocal, so that's negative square root of a squared plus 1, which is over 1. So I'm not going to write it. And then I already know what tangent is from here. So cotangent of theta is just the reciprocal of a, so it's 1 over a. Guess what? I'm done doing the homework problems that I'm going to do. I know there's a couple for y'all left to do. See you tomorrow.